Welcome guys. Go we start solving our physics GRE 83. So basically you have the two charges have the same mass and they have the same mass and the same charge. And then you know the length for this is L and this is this D, and they ask you about the what's the D. So basically you can say the charge has three forces. One is mg, one is the kq square over d square. This is Coulomb force, and so you have these two forces and the tension. So they forms a triangle. So this kq square over d square divided by mg is basically tension, and the tension is just d over 2 divided by basically this tangent. So you need to approximate as a sign because theta is small. So this tangent is approximated to d over 2 divided by L. So from here we can solve d to the cube. Basically it's 2L kq squared divided by mg. So d is equals to this one. 2L kq squared divided by mg, 1/3. So the answer is A. The answer is A. Okay, so 84 said that there is an electron oscillates back and forth with plus or x plus and minus x-axis, and it emits the electron. So emits the radiation. So this is the radiation, and which was not true. So A, the total rate of radiation energy into all directions is proportional to the square of the directions. That's the square of the electron acceleration. This one is correct or not? Remember, there's a formula. Say that the power is this one. Basically, this formula you need to remember. What you need to remember is that this acceleration square. So the answer is A. The A is correct. Sorry. B said the total rate of radiation into the direction proportional square of the electric charge. Electrons charge. This is also correct. C, far from the electron, the rate of radiation stored across a perpendicular unit area decreases the inverse of. Okay, so why is perpendicular? And D say that the rate which radiation across the perpendicular unit area is maximum when the unit area is located plus or minus x-axis. And say that E, that the far from electron radiation energy is carried equally by a transverse electric field and the transverse magnetic field. So basically, from the concept of standard EMM, we can say that A, B, E are all correct. A, B, E are all correct. How about C? So C say that the electric, when you are very far from the electric field, the radiation across the perpendicular unit area decreases inverse square. So basically, if you remember the Leonard visual potential, you can write down the plus a lot of terms, but 1 over r. So this is the original Coulomb force. This is the radiation. And the denominator numerator on this term is n times n cross something. So basically C is correct. Because they say the perpendicular unit area, so which is this term. So the D is not correct. D is not correct. Okay, then 85 easy. You know that the total energy is momentum squared plus c squared. plus m squared. If c equals to 1, so we have 1.5 squared minus 0.5 squared equals to p squared. So p equals to 1.4. Close. So the answer is C. Answer is C. 86 say that you can read the question by yourself. Basically, if the switch is all closed and then open, one can calculate so the keys we want to calculate is C. So how can we calculate it? So basically, this is the RC circuit. The RC circuit. So when you close, then it will charge. When it open, it will start to dissipate the Q into the system. So this is the standard RC circuit time factor. So based on this graph, then you can measure this RC. So basically, once you know this constant speed S and R, you can get a C, because constant speed S can give you the time scale, and you can use time scale to calculate the capacitance. So the time scale is RC. So the answer is B. That's it.